In fact, we got a lot to finish this. Not just properties of radicals, but the other two subjects afterwards. But I kind of want to test you on properties of radicals. Tell me what that simplifies to.
To the square root of 4 and the square root times the square root of 2.
Well, you don't want to write that answer as that. In other words, you're right. That is the square root of 4 times the square root of 2, but that's not simplified. What does that simplify to?
2 times the square root of 2.
There you go. That's the answer right there. Okay. Now, a little harder. Tell me what the square root of 40 is.
It would be the square root of 4 times the square root of 10. And then it would, what would it be then?
Well, what do you think?
Well, because 10 divided by 4.
Start with that. Start with the square root of 4. What is that?
It's 2.
So, you're saying that it's that. Now, the only question is that the final answer, or do I want to make it this? Which one is simpler?
The first one.
That's the answer. In other words, you don't factor it just because you can. You only factor it if you can pull a whole number out. And I was able to with the square root of 8. But with the square root of 10, you cannot pull a whole number out of that. It is equal to the square root of 5 times the square root of 2, but that doesn't simplify it. So root 10 is always root 10. We never simplify it. And root 8 always becomes 2 root 2. All right. Use product property of square roots. That's relatively simple. They're saying that what is the square root of 3 times the square root of 3 equal to?
The square root of 9.
Okay, which is what number?
3.
Ah, there's the key. In other words, the square root of x times the square root of x equals x, no matter what x is. That's pretty much what they mean when they say the product property of square roots. Is that, notice that there's another way I can write this. I'm not sure you're familiar with this, but we're going to get to it in these topics here. But the square root of x can be written x to the 1/2, that's the same, times x to the 1/2. When I multiply two things that are the same, I add the exponents. So that becomes x to the 1. You with me?
Mm-hmm.
This is often an easier way to really look at it because it's very straightforward. In other words, once you have fractional exponents instead of radical signs, it actually makes the problem a lot easier. You're able to just add or subtract the exponents. Okay, what would this be? X to the 3/4 divided by x to the 1/4. What's that equal to?
X to the 1/2.
You got it. And so you can see that even complicated stuff, it's much easier to handle if you have fractional exponents. Because otherwise I would have to write that as the 4th root of x cubed, that's the numerator, divided by the 4th root of x. In other words, that is the same as that. But it's so much easier to deal with if you have the fractional exponents, because you can subtract them if you're dividing, and you can add them if you're multiplying. All right. Use product property of square roots. So let me just give you one more example. What's that equal to? That's the product, because I'm multiplying the base. So what do you do with the exponents?
You would add them.
Okay, so it's equal to x to the 1/2 plus 1/3. Now add those two fractions. What's 1/2 plus 1/3 equal to? What do you have to do first?
Oh God, I don't remember.
Least common denominator. Always remember, when you're dealing with fractions, it's very difficult to add and subtract them unless they have the same denominator. So what's the least common denominator between these two fractions?
6.
Okay. How many sixths is 1/2 equal to?
3.
How many sixths is 1/3 equal to?
2.
So when I add 3/6 plus 2/6, how many sixths do I have?
5/6.
That's the answer. X to the 5/6. And I could write that this way, the 6th root of x to the 5th. You understand that right there? In other words, the denominator of the exponent is always the root, and the numerator is always the power. So x to the 5th sixths is the same root, or is the same answer as the 6th root of x to the 5th.
Got it.
Okay, good. Let me test you. What's that equal to? Always begin with the denominator. In other words, always take the cube root of 8 first. Don't square 8 first. It'll result in much bigger numbers. If you take the cube root, if you take the denominator first, then you're always dealing in small numbers. What's the cube root of 8?
I'm not sure.
Know that the answer is a small whole number. It's either 1, 2, 3, or 4. So which of those numbers multiplied 3 times equals 8?
Wait, okay, so
What's 2? It's not 1, because when you multiply 1 by itself, no matter how many times you get 1. In other words, 1 times 1 is 1. 1 times 1 times 1 is also 1. So it's never 1. So these answers, when you get questions like that, the answer is either 2, 3, or 4. Okay? And start with the denominator. What's the cube root of 8? Well, what's 2 times 2 times 2 equal to?
8.
That's the cube root of 8.
Okay.
That's how you figure it out. Is it what number multiplied by itself 3 times is equal to 8? So what we really have here is 2 squared, right? In other words, if we do the denominator first, that gives us 2. And then we have to do the numerator. So 2 squared is 4, which means 8 to the 2/3 power is 4. And now, whoops, hold on a second. I didn't really want to get rid of that. Hold on. Notice that you actually can do these in any order you want. I could square 8 first. So I could take 8, square it, and take the whole thing to the 1/3 power. Do you see where those are the same?
No.
Well, what's 8 squared?
64.
That's where I got the 64. In other words,
Okay.
if I act on the numerator first, I'm going to square the 8. Then I'm just going to have the denominator left, which is 1/3. Well, the cube root of 64 is 4. The problem is that I had to square 8, which gives me a rather large number, 64. You always want to do math where your numbers are as small as possible. Well, notice that if I take the cube root of 8 first, I get 2. I still got to do the numerator, which is squared. So I get 4, and notice there's no number there bigger than 4. I don't have to deal with a number as large as 64. So you always do the bottom first. And when they give you problems like this, it's always going to be of this nature, where the answer is a whole number. So what's that? Do the bottom first.
It's 3.
Okay.
What? 3
Keep going.
cubed?
No, you did the bottom already. That's how you got 3. You took the cube root of 27. Now do the top. What's 3 squared?
9.
Okay, that's your answer. In other words, I do the bottom first, and I get 3. The cube root of 27 is 3. And then I square 3 to get 9.
Got it.
Okay, good. And that's kind of more coming up. We still have to work with this part right there. And that's a lot of red meat. So, in other words, we've got a lot of work to do to cover this last, what I have a circle next to there. So, it says start with solving quadratic equations using square roots. Well, let me give you the most simple one that I can think of. There's a quadratic equation, and the reason it's a quadratic equation is because we have x squared. If I just had x, it would be linear. If I had x cubed, it would be cubic. It's quadratic only if you have an x squared. How do I solve this equation?
Use the square root of it.
In other words, I do this and
You square it. Okay.
okay,
And just,
I take the square root of both sides. And here's also what I'm doing. In other words, let's look at it maybe a way that might be a little more helpful. If I take both sides to the 1/2 power, now using your rules of exponents, what's the left side become? Multiply those two. When you have double exponentiation, you multiply them.
So 1.
Yep, which means it becomes x. And now, what's the square root of 25?
5.
Actually, it's plus or minus 5. And that's key. That's the biggest mistake you're most likely to make, okay, is leaving out the plus or minus. And trust me, you will lose points on any test you take. So, and this is maybe one of the biggest mistakes my students make. And I'm not quite sure how to keep them from making it. I tell them that whenever you solve an equation by taking the square root of both sides, always begin your answer with the words plus or minus. So, what's this?
It would be 2. Plus or minus 2.
Plus or minus 2. And those are two different answers. When I write that, that means there's two answers. There's x equal 2 and there's x equal minus 2. So if you write x equal 2, you're omitting half of the answers. You'll lose half credit on any test. Okay? So that's really one of the only things I can tell you is that when you solve an equation by taking the square root of both sides, always begin your answer with the words plus or minus. Solve that. This is 2 steps. This is not 1 step. This is 2 steps.
Okay, so I think you still start with squaring it, right?
Square rooting it.
Square rooting it.
This is squaring. Square rooting is that, or taking it to the 1/2 power. So they're completely different. You need to distinguish between them. And
Okay.
since we're trying to get this isolated for x, well, the first step is we can isolate x minus 2 by square rooting each side. So what's the next line?
It would be x minus 2 equals 5 plus or minus 5?
Plus or
No,
minus?
just
Always.
okay.
Like I said, the rule is if you're solving an equation, and this is a little bit of a tough distinction. If I say the square root of 25, that's actually only 5, okay? If I want minus, I do this, and that's equal to minus 5. So if I'm looking at a radical sign, it's the positive answer only. That's by math convention. But if I'm solving an equation by taking the square root of both sides, it's completely different. If I'm solving an equation by taking the square root of both sides, my answer has to begin plus or minus. Now, what's the last step? So if x minus 2 equals plus or minus 5, what's x equal to?
Plus or minus 7?
No, it's plus or minus 5 plus 2. Right? In other words, I get there by adding 2 to both sides. With me?
Okay. Yeah.
Now, treat this as 2 separate answers. What's the first answer, which is plus 5 plus 2?
Oh, so 7.
What's the second answer, which is minus 5 plus 2?
-3.
There you go. That's how you handle that. And that probably is pretty much all you need to answer or to talk about using product property of square roots, or solving, rather, the first part of solving quadratic equations using square roots. The tough one is this one right here, completing the square. We've got about 10 minutes. We can kind of get started here. Let me give you an equation like, hold on a second. Let me think for a moment. There is a quadratic equation in standard format. Notice why it's in standard format. Everything's on the left side, zero's on the right side. All your x terms are on the left side, even your constant is on the left side. If I said solve that equation, your first step would be to try to factor it, right? But there aren't very many factors of 11. It's 11 and 1. That's it. So this thing doesn't factor. In other words, I cannot write that as x plus something times x plus something else. I wish I could, because then I could solve it easier. But there is another way to solve this, and that's completing the square. And completing the square is actually used in a number of different things. It's when you have a quadratic that's in standard format and you want to put it in vertex format. Completing the square is beautiful. Or if you're dealing with conic sections, completing the square is very, very common. So let's talk about the general process of completing the square. First of all, I'm going to combine those two terms right there. Okay, and I'm going to rewrite it as x squared plus 6x. I'm going to write it in parentheses like that. I'm going to leave some room up here. Now, notice I have not changed anything. Now I'm going to do, in other words, I've got all of the terms that have x in it in parentheses. And the way to complete the square here is to take half of this coefficient of x and square it and add it. So what do I want to add? Half the coefficient of the x term and square it. That's always what you're at.
Which one's the coefficient?
Well, that's whatever number is in front of the x term. What number?
Okay, so is it 6?
Okay, now take half of that and square it.
So it's 9.
Okay, so that's how I complete the square, always. No matter what that middle number is, I take half of it and square it. Now, the fact is I just added 9 to the equation. You can't do that unless I subtract 9 at the same time. Then I can do it. In other words, here, let's go to the left. In other words, if I say this, well, hold on. Let me write that a little different. It's liable to be confusing, but this is a tough subject, so just bear with me. Plus 11 minus 9 equals 0. Do you see that this is the same as what I started with? In other words, the 9's cancel, right?
Yeah.
And I end up with x squared plus 6x plus 11 equals 0. So I really haven't changed it. And that is the secret to completing the square, is you don't want to change the equation at all. You want to make sure that it's the same equation you started with. Well, now this becomes x squared plus 6x plus 9. And I'm going to put parentheses around it. And 11 minus 9 is 2, right?
Mm-hmm.
So now I have that, and that's the same as what I started with. But the beauty of this is that I can rewrite what's inside the parentheses as x plus 3 quantity squared plus 2. So I can say that's my function. That's the same thing that I started with. That is x squared plus 6x plus 11. The only thing is it's now in perfect vertex format. So I know exactly where the vertex is. Where's the vertex? Remember what the vertex format is. It's y equals a times x minus h quantity squared plus k, where h and k are the vertex. So I'm looking at that. A is 1, right? There's a 1 out here. What's
Mm-hmm.
h? What's h?
3.
No, it's x minus h. So what's h? Minus 3.
Oh, okay.
You see why?
Yeah.
In other words, if h is minus 3 and I have x minus a minus 3, it becomes x plus 3. So if I'm looking at a plus sign, it generally means h is negative. What's k?
2.
That's the vertex. Vertex comes at minus 3, 2. So notice what happened. I started with a very complicated quadratic that I could not factor. And by completing the square, I was able to put it into vertex format, which is this format right here. Get used to that format. That is the most common format for quadratics. And the reason it is because it shows you immediately where the vertex is. In other words, whatever h and k is, that's the vertex. And there's no point more important on a parabola than the vertex. That's the very first point you want to know where it's at. So when you can take a quadratic and put it into vertex format, you've accomplished a lot. You immediately know where the vertex is. It's at h, k. But the only way you can take a complicated quadratic and put it into vertex format is by completing the square. Okay? So this is a pretty important process. Like I said, it's a big subject. And 7:30, that's probably a good place to stop. All three of these are actually big subjects. Using square roots to solve an equation, completing the square, and the quadratic formula. All three of those are big subjects. And unfortunately, they're probably going to test you on all of them also. In other words, this whole page that you've given me here, that's Algebra 1 in total. In other words, every single subject, if we get through the end of this thing, you will have gone through an Algebra 1 course, totally. So, you might expect that some of these are going to be big subjects because an Algebra 1 course is 2 semesters long. That's 9 months. And you and I are trying to cover this in like 2 months, doing an hour and a half a week or 2 hours a week. So we can make some progress, but I don't know that we can make the same kind of progress that you'd get in a class. But I still maintain my position that you're so much better off taking geometry this year than going back and taking Algebra 1. I'm pretty sure that by August 16th, when you go back to school, that you're going to be able to pass a basic algebra test. Enough that they will say, yes, you can stay in geometry class. And that's our goal, okay?
Yeah.
We don't want you having to go back and retake Algebra 1. It won't be a total waste what we've done all summer because you'll do really, really well in it. But what it will do is set you back as to what you'll be able to take as a sophomore and as a junior and as a senior. And I think you have a certain amount of math skills that you want to keep your options open to be able to take calculus as a senior. And in order to do that, you have to take geometry as a freshman, not Algebra 1. So that's why I'm pushing so hard for you to take geometry, because I really think you can do it. And I can certainly work with you when you take geometry in your freshman year. And like I said, by the time you go back to school, we should be a little further through this list, and you should be able to do quite well on algebra, and any Algebra 1 test. All right?
All right.
Okay, Phoebe. I will talk to you next time.
Yep, sounds good.
All right, bye-bye.
Bye.